Hey, welcome to the video about writing compound inequalities in interval notation. In the last video, where we looked at some examples about minimum and maximum weights to zipline, discounts about being under 12 or over 65, we did look at compound inequalities, graph them on a number line, and wrote them in interval notation. So these are some more examples, just algebraic examples without context to practicing with and or. So the first compound inequality you see is a three-part inequality, and we're going to explore that more in a future video. So let me just kind of give you the what is this saying here? It's saying that negative 3/4 is less than x. Less than or equal to x. And x is less than 1/2. Okay, so there's really two different things that this is telling us. So we're going to graph this on a number line. So here's 0, we'll just put 0 in the middle. We have -1 out here and +1. So negative 3/4 would land, about there, and 1/2. Now that's not quite exactly in the middle of 0 and 1, but close enough. Okay, so if we want to say that x, negative 3/4 is less than or equal to x, reminder that that could also be turned around. X is greater than or equal to negative 3/4. So we have negative 3/4, x is greater than, so that goes to the right. I'm going to change to red for our second inequality. If you're taking notes, I suggest for these videos to also take notes in kind of color code. If we have x is less than 1/2, well, that can't be equal to 1/2. That would be just strictly less, and that would go that direction. For the word and, very special meaning, that means both of these statements have to be true for whatever x is. So if I'm looking at 1, if I look at this number, if x is 1, well, 1 is certainly greater than negative 3/4. It's in that blue shaded region, but 1 is not less than 1/2. It's not in the red shaded region. And because of this word and, it has to be both. Both statements have to be true. 1 does not make that true. Same thing with -1. -1 is less than 1/2. It's over here in the red shaded region, but it's not in the blue. So for the word and, it has to be true for both. So I'm going to use black here, and this is our final solution right there on our number line. It's the overlap because it's and. In interval notation, I always like to do the graph before interval notation because I can get interval notation right from the graph. This says, okay, start at negative 3/4, include that, up to positive 1/2, but don't include that. So we use that parentheses. Okay. Here we have another compound inequality. It's not a three-part like the previous one. X is greater than 5 and x is less than 9. So what numbers are greater than 5 and less than 9? Well, 6. 6 is greater than 5 and 6 is less than 9. So let's see what this looks like on a number line. Again, then I suggest doing the number line first because the number line will then basically give you that interval notation. So here's 0, we'll put 5 here in the middle, and double that would be 10, so we're going to say 10's that. We'll put 9 right before that. So color code, x is greater than 5. Greater than 5, but not equal to 5, so we use our parentheses, and I'm going to go all the way this way. Let's look at x is less than 9. Not including 9, so we use parentheses, And what numbers are less than 9? All of these numbers. 0 is less than 9. But we need them to both be true because it's and. X has to be greater than 5 and less than 9. So out here, 0. Let's just talk about the number 0. 0 is not greater than 5. It is less than 9, but it's not greater than 5. So 0 is not part of the solution to this compound inequality. And 10 is greater than 5. So if I'm looking at 10 is greater than 5, but it's not less than 9. So 10 is not part of the solution. But if I pick something like 6 that we talked about before, 6 is greater than 5 and 6 is less than 9. So our solution is where this region that's been shaded both red and blue. So we will mark that as in black, greater than 5, but up to 9. And that gives us the interval 5 to 9, using parentheses, just like we did on that number line. So those are two examples of compound inequalities with implied and. Now we're going to look at some inequalities where we're using the word or. So here, solutions need to be less than -4 or greater than 0. They don't need to be true at the same time. Or means one or the other. Okay, so here we'll put 0 and sort of in the middle. We'll put -4 out there. And I'll just, for symmetry, I'll put +4 on the right. Color coding. What x is less than -4? So we cannot be equal to. We use that parenthesis. Numbers that are less than -4 would be in this direction. Looking at x is greater than or equal to 0. I'm going to use the bracket because it could be equal to 0 and go that direction. And again, both of these don't need to be true, just one or the other. This is going back to that example of you can get a discount if you're under 12 or over 65. You can't be both of the, you can't be both under 12 or over 65. You can get a discount if you're one or the other. So we don't need the overlap when we see the word or. And if I'm looking at this in interval notation, I just look from that number line, looking at it from left to right. Here we have -infinity. That blue arrow would go off to -infinity. So -infinity up to, but not including -4, together, union, with 0 up to +infinity. Okay, in this next example, let's read it first. We're wanting the inequalities to be, the solution to be all the numbers that are less than or equal to -6 or greater than -11. So let's take a look at this on the number line. We'll just put 0 out here because we've got -6. And then we'll put -11 right there, almost double the distance. X is less than or equal to -6. So we want to include -6 because it could be equal to, and we want numbers that are less than, all the way over here. I'm ignoring that 11 when I think about this because I just want to look at what would, if x were less than or equal to -6, what would that be by itself? Now I'm going to consider in red when is x greater than -11? Okay, so ignoring the blue, and here's -11. We want the numbers that are greater than that. Okay. This is different. This has overlap, kind of like the ones above did. But now we have to think, what is going to be in the answer? So let's just look here at -12. Is -12 less than or equal to -6? Negative 12 less than or equal to negative 6. Yes. Or, so we'll put or, is negative 12 greater than negative 11? No, it's less than. So this one isn't true. I'm kind of putting a little X there. But we have an or. We don't need them both to be true. So negative 12 is a solution to this compound inequality involving or. Let's also look at 0. And we'll check 0. Is 0 less than or equal to negative 6? No, 0 is greater than. That one doesn't work. But it is greater, 0, not 6. 0 is greater than negative 11. So 0 is part of the solution. Certainly anything in this region, let's say negative 10. Negative 10 is both greater than negative 11 and less than or equal to negative 6. So that would work too. If it's true for both, it's definitely true for one or the other. Think about that sentence, this summer I want to go to Iceland or Australia. If I went to both, that'd be awesome. That's fine. So it can be true for both. It just needs to be true for at least one. So where on the number line is it true for at least one? The whole number line. It's certainly all of these are true for the blue. This is true for both. And this region over here to the right is true for the red. So the whole number line works for these this compound inequality. So what we say is it's all real number solution. And in interval notation, we write that as negative infinity to positive infinity. Okay. So before moving on to the next video, I'm going to give you some inequalities to try. And also note that there are more resources in your textbook on interval notation back in chapter 1. So if you need, if interval notation is, if you need some refresher on that or about inequalities in general, look those up in your textbook online. Okay, so the directions to these are you're going to write in interval notation and graph on a number line. And remember, my advice is you graph on the number line first, and then the interval notation will just fall out from that. So first one to consider, graph negative 5 less than or equal to x less than 2. The second one, excuse me, x is greater than 0 or x is less than negative 3. And then 3 and 4 are going to look pretty similar, but the difference, it will be in the symbols, so pay close attention. This one's x is greater than negative 3 and x is less than negative 1. And number 4, x is less than negative 3 and x is greater than negative 1. So try those, bring those solutions to class, and we'll check and see how you did.